We're going to answer this question before us. It says that we need to list the sequence of transformations which takes the graph of this to the graph that. So ideally, when you're faced with these type of questions, you want to follow dilations, then reflections, then translations. That's the order you want to follow. The next thing that you want to do is you want to take this and you want to factorize inside the square root here. So that means I'm going to end up with 7 on the outside, the square root, and then I'm going to write this as 3x plus 4 on 3. And now I can just read off my dilations, then reflections and translations, just a bit easier. So I'm going to begin by saying we're going to dilate by a factor of 7 from the x-axis and by a factor of 1/3 from the y-axis. So what is this saying? So I'm looking at my dilations. This 7 is saying that I'm going by a factor of 7 from the x-axis. And I also know that this 3, because it's affecting the x here, is dilating from the y-axis, and you have to take the reciprocal of it. You have to take the reciprocal of it. If that confuses you, we'll go also through how to do this by the method. We'll make, which will take us a bit more time, but it's an alternative way of doing this to show you that. Otherwise, this is just doing it by inspection, and it's just really quick. Now, there are no reflections happening here. So then the last thing we simply have to say is 4/3 in the negative x direction, because you got a plus there. And make sure you use the correct language. You're going to say followed by a translation of 4 on 3 units in the negative y direction, x direction, sorry. So that is reading off that. Perfect. Now that is how to do it the quickest way. And that was pretty quick. You can do that in like a minute. If I wasn't talking, I could have done that, in a few seconds maybe. But if you're thinking, well, that's a little bit complicated, I want to do it the slower way. Remember, this method is called inspection. But the other way to do it is by the method, which does take a little bit longer, but some people think that they are less likely to make a mistake if they do it by the method. So let's go through that way. So we're starting with a point, and we're going to a new point, x dash, y dash. Our original point is on the graph y is equal to x, and our new transform point is y is equal to, and then we're just going to write down 7, the square root, and I'm actually going to write it down in the non-factorized version, so 3x plus 4. 3x plus 4. I'm going to put my dashes on the transformed one because my transformed point exists on the transformed graph. Once I've done that, I then want to rearrange this. So I divide that by 7 so that it looks like this. And now what I can do is I can say, all right, let this y be equal to this, and then let this x be equal to that. And don't forget your dashes, there's still a dash there. So that means y is going to be equal to y dash over 7, and x is going to be equal to 3x dash plus 4. That means once all is said and done here, what I'm going to end up with, whoopsie daisy, is y, or 7y is equal to y dash. And then over here, I'm going to get x minus 4 divided by 3 is equal to x dash. To write this another way, I could say x over 3 minus 4 over 3. And now, if we just zoom right out for a second, hopefully you can appreciate how what we've found is actually telling us the same thing by doing it by inspection. So if we look here, I'm timesing my y value by 7. That's telling me we're dilating by a factor of 7 from the x-axis. Because remember, when you're dilating from the x-axis, it's affecting the y value. You're then reading this off, you're dilating by 1/3 from the y-axis, because that's affecting the x, 1/3 from the y-axis. And then, as you can see here, I am minusing 4 on 3 from the x in the x direction, and that's a translation of 4 of 3 in the negative x direction. Either way works. Either way doesn't really take that much time. It's just what way you feel more comfortable with. Hopefully that makes sense on how to do that. And yeah, I'll see you in the next part.